Alright, hi guys. Today we are going to talk about solving equations using square root and cube root. So let me give you just an example, kind of introductory equation. When we first learned how to solve equations, let's say we had x plus 3 equals 10. We learned that to solve it algebraically, we need to get the x by itself. And to do that in this case, we would look at both sides of the equation and say what's in the way of having the x by itself, the plus 3. So we would do the inverse operation or opposite operation. To get rid of plus 3, we'd subtract 3. And whatever we do to one side, we have to do to both sides. So that would cancel out. The inverse operations cancel, and you get x equals, and 10 minus 3 was 7. So we know this. We know how to solve equations using adding, subtracting, using multiplying, dividing. Well, today we're going to talk about another set of inverse operations, and that is squares and square roots, or cubes and cube roots. So a little side note again, if I told you, let's see, 7 squared. If we were talking about 7 squared, squaring that, giving that an exponent of 2, is an operation. What's the opposite of squaring something? The opposite of that, or the inverse of that, would be to take the square root. If I did 7 squared, that would technically be 49. What if I took the square root of 49? I would get back to just the 7. So if I square something and then take the square root of it, they cancel each other out because they're inverse operations, and I'm left with whatever I started with. So that's the principle we're going to use today to start solving equations using square root. So let's do our first example, example number 1 with square roots. Let's do x squared equals 36. Let's say that's the equation that we're given that we want to solve. Same idea, we want to get the x by itself. So what's in the way of having the x by itself? That's squared. And to get rid of the squared, we have to do the inverse operation of squaring, just like up here. How do we get rid of the squared there? Well, we'd take the square root of it, and it would make it go away, so all we'd have left would be our x. The square root of x squared, those two cancel out. It just becomes x again. So I can do that. I can do whatever I want as long as I do it to both sides. So I need to also take the square root of this side. And in doing that, all that remains on the left-hand side is an x. And over here, the square root of 36. So this, we have to do some figuring out. We're going to ask ourselves, what times what is 36? And it's going to be 6. So we can tell, if we went back into this original equation, the original one was x squared equals 36. Is 6 a solution? Could we plug it back in and check? Sure. 6 times 6, 6 squared is 36. But there's also kind of an invisible solution to this, something else we have to consider, that it's not just a 6 times 6 that would be 36, but we also know that a negative times a negative is still a positive. So this could be 6, but this could also be negative 6, and that would work as well. So whenever we're taking the square root of something, we have to consider both the positive and the negative version might be a solution. So here's the notation that we'll use for this one. When it could be a positive 6 or a negative 6, we do this symbol, plus or minus 6, and that would be the solution. So you don't have to do both of these steps anymore. Whenever you're taking the square root, you get the number, and you could say it could be plus or minus. So let's do one more quick one like that. Example number 2. If we've got x squared equals 25. To get rid of the squared, we take the inverse operation. We take the square root of both sides, and the square root of x squared cancels each other out. We get x equals, and the square root of 25, what times itself is 25? 5. But we know that 5 times 5 could be 25, or negative 5 times negative 5 could be 25. So plus or minus 5 is our solution for this one. So that's all the work we're showing. Pretty quick once you get the idea of doing the inverse operation. All right, let's go to one more of these. Can we do x squared equals 72? We're going to look at that one. X squared equals 72. If we're going to take the square root now, to get rid of squared, we take the square root. So square root on both sides. Square root and squared cancel each other out, and we get x equals. Okay, square root of 72. Is that a whole number? Is something times itself as a whole number 72? Nope. So this one we're going to have to do a little work to simplify. Really, whatever it is going to be able to be a positive or a negative, right? Anytime we're taking the square root, it could be positive times a positive or a negative times a negative. So right now, all we know is that it's a positive or a negative, and whatever the square root of 72 is. So that would be a possible solution. Now, there is also a way that we're going to have you guys learn that simplifies this answer right here. And there's another video later on that you guys will find that teaches you how to simplify radicals, it's called. So that will be something else that you want to look at, and you could make this look like a simpler form. But right now, do you understand that it needs to be either a positive or a negative, and whatever that number is right there. So you won't always have a whole number answer to it. All right, so find that instruction video on how to simplify radicals, and you'll be set for that process. Let's do just a couple with cubes right now. Example number 4. This time it won't be squared. Let's do x cubed equals 27. So the same idea as squared, we want to do the inverse operation, and the opposite or inverse of taking something to the third power, of cubing something, is taking the cube root of it. So if I did x cubed and wanted to undo that, I would take the cubed root. That would cancel out. Whatever I do to one side, I have to do to the other. So I want to know, what is the cube root of 27? What times itself 3 times is going to be 27? What cubed is 27? It's going to be 3 times 3 is 9, times 3 is 27. So the cube root of 27 is going to be 3. And guys, you can just guess and check on these on a calculator. If you're not sure, try. Hey, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. Use some educated guessing to try and figure out cube roots. On a simple calculator, there is no button for cube root, just so you know for the future. So you would have to do guessing on a simple calculator anyways, but these are all the ones right now are going to be easy enough that you can figure them out mentally. All right, what about this over here? So cube root and cubed cancel each other out. This one we said 3. Okay, here's the question. Is this going to be a plus or minus 3? Could this be positive or negative? Well, if it's a positive, 3 times 3 times 3, 27. Yep. What about negative? What's negative 3 times negative 3 times negative 3? Negative times a negative would be a positive 9, and then positive 9 times negative 3 is going to take you to a negative 27. So we can't get a positive 27 from negative times negative times negative. So in the case of a cube root, can our answers be negative? Can you ever have a negative times a negative times a negative giving you a positive? No. So in this case, it's only going to be that x equals a positive 3. All right, let's do one more cube root equation, and we'll be done with notes. You'll have it. So for this one, let's do x cubed equals